Problem number 4, I've got a function machine here. The input represents a number of weeks, and then the function sends out how many days this represents. So letter A, if I put 4 in, that means 4 weeks. Well, how many days are there in 4 weeks? It would be 4 times 7. In other words, 28 would come out. Find f of 6 means put 6 in, that would be 6 weeks. What's going to come out? 6 times 7 would be 42 days coming out. Now we have the inverse function. The inverse function reverses the process of the original function. So now the days goes in and the weeks come out. So if I put 21 into the inverse function, that would mean 21 days. The function is going to tell me how many weeks that represents. 21 days would be 3 weeks. F inverse of 70 is how you would read that. That means put 70 into the input function, 70 days. How many weeks would that be? Just divide by 7. That would be 10 weeks. How about F inverse of 3.5? That would mean 3.5 days. Well, 3.5 is exactly half of 7, so this would be half of a week. And then letter F, I'll work it out in pieces. Take 14 and put it into the inverse function. So 14 days, put it in the inverse function. I'm going to get out 2 weeks. Then take that 2 and put it into the main function. Well, the main function was the one where we put in the weeks, 2 weeks, and we got out the days. Well, 2 weeks would be 14 days. So the final answer here to part F would be 14. After you do this for a while, you might remember that if you run a number through both its inverse function and its original function, you're just going to end up with what you started with because the function and inverse function reverse each other. Problem number 5, we're being asked to solve this equation for x. We're not going to get a number, though, as the answer. We're going to get an expression involving these other letters, these constants a and b. So I'll pretend that x is my only variable, that a and b are just numbers. Looks like I should distribute here in order to get rid of those parentheses. And that if I want to solve for x, I need all of my terms with an x on one side and all of my terms without an x on the other side. It looks like the easiest way to accomplish that is to subtract this bx from both sides. Now, if a and b were just numbers, we'd carry out the subtraction on the right. But since they're not, I'll need to use a little trick here. And the trick is simply to factor out that x on the right side. So I'll pull that out to the front as the GCF. I now have the letter x written only once, which is good. I want to get that x by itself. In fact, the only reason it's not by itself is that it's being multiplied by this a minus b. If I simply divide both sides by a minus b, I'm done. Final answer, x equals 10b on the top divided by a minus b on the bottom. I have no way to simplify that, and so here's the final answer. Problem 6, let's see, in letter A, we're being asked to find the measure of angle theta. I know the 3 angles have to add up to 180. I've got a right angle, so that's 90. That means these other 2 must add up to 90 degrees. So all I'd have to do is 90 take away 53, and you can check that comes out to be 37 degrees for angle theta. In problem B, I'm now looking for the measure of a side. I do have a right triangle here, which means I can use the Pythagorean theorem. I would have x squared plus 21 squared, the sum of the squares of the legs, is equal to the hypotenuse squared. I'll get these values from the calculator. I have x squared plus 441 equals 529. Subtract that 441 from both sides, and that gives me x squared equals 88, and then just square root each side. We don't want a decimal, we want the exact simplified answer. I know the answer is positive. Let's see, 4 is a perfect square that goes into 88. 4 times 22 would make 88. So I can take the 4 out as a 2 22 would stay inside, and there's my final exact simplified answer. X equals 2 times the square root of 22.